So in this video we are going to discuss De Moivre's theorem, LAQ, PYQ. The question is, if n is an integer, then show that 1 plus I whole to the power of 2n plus 1 minus I whole to the power of 2n, which is equal to 2 to the power of n plus 1 into cos of n pi by 2. See, in the solution, we have 1 plus I, which is equal to, so we can write, so multiplying numerator and denominator by root 2, so root 2 into 1 plus I whole to the power of 1 plus I whole divided by root 2. So which can be written as root 2 into, so this is 1 by root 2, so plus this is I into 1 by root 2. So now which becomes, which is equal to root 2 into this 1 by root 2 in terms of cos, we can write cos pi by 4 plus I into sin pi by 4, this is 1 by root 2. 1 by root 2 is in terms of cos pi by 4 plus I into, so 1 by root 2 is again in terms of sin pi by 4. Now what is there? We have here 1 plus I whole to the power of 2n, so which is equal to root 2 into, so cos pi by 4 plus I sin pi by 4 whole to the power of 2n. So which becomes, so root 2 means 2 power 1 by 2, so whole to the power of 2n into, this is cos pi by 4 plus I sin pi by 4 whole to the power of 2n. So we know that the De Moivre's theorem here, so the property is we have cos theta plus I sin theta, suppose cos theta plus I sin theta whole to the power of n, so which is equal to, we can write, so cos n theta plus I sin n theta. Cos theta plus I sin theta, when you apply the De Moivre's theorem, this is multiplied by n theta multiplied by n, so that is cos n theta plus I sin n theta. Similarly, for this, if you apply the De Moivre's theorem, we get here 2 gets cancelled, 2 to the power of n, so into, so this is cos 2n pi by 4, this is 2n into pi by 4, 2n pi by 4, and plus here I sin, so 2n into pi by 4, that is 2n pi by 4, when you apply the De Moivre's theorem. So now here 2 times it gets cancelled, this is also 2 times we can cancel, we can write 1 plus I whole to the power of 2n, so which is equal to 2 to the power of n into cos of n pi by 2 plus I sin of n pi by 2. I sin of n pi by 2, say this is condition 1. Now further, here we have one more complex number, 1 minus I. So now 1 minus I, which is equal to, so this is also can be multiplied by numerator and denominator by root 2. Root 2 into 1 minus I whole by root 2. So which becomes root 2 into, this is 1 by root 2 minus I into 1 by root 2. I into 1 by root 2. So now further, which is equal to 1 minus I, which is equal to root 2 into, this 1 by root 2 is writing as cos pi by 4 minus I sin pi by 4 again. So it can be written as root 2 into, in terms of cos and sin, cos pi by 4 minus I sin pi by 4. So now 1 minus I whole to the power of 2n we have here. So which is equal to root 2 into, so cos pi by 4 minus I sin pi by 4 whole to the power of 2n. See, when you apply the De Moivre's theorem for this, so this is root 2 means 2 to the power of 1 by 2 whole to the power of 2n. So into cos, when you apply the De Moivre's theorem, same like this, so we get 2n pi by 4, this is, so and also here plus I into sin of, so minus 2n pi by 4, minus 2n pi by 4. You can keep minus here also. Why? Because here cos of minus theta is always only cos theta, and sine of minus theta is, we know that, so minus sine theta. So it can be written as, so cos of minus 2n pi by 4 and plus I sine of minus 2n pi by 4 when you apply the De Moivre's theorem. So then here 2 gets cancelled, which is equal to 2 to the power of n into, here if you cancel it, we get cos of minus n pi by 2, and here plus I sine of, here also 2 times we can cancel, minus n pi by 2. See here, so finally we get 1 minus I whole to the power of 2n is equal to 2 to the power of n into cos of minus n pi by 2 plus I sine of minus n pi by 2. Say this is 2. So here from 1 and 2 we get here, what is LHS here? 1 plus I whole to the power of 2n plus 1 minus I whole to the power of 2n. So now LHS is equal to here, adding 1 and 2, which gives 1 plus I whole to the power of 2n and plus 1 minus I whole to the power of 2n in the left hand side. So which is equal to, right hand side we have, so 2 to the power of n into cos of n pi by 2. So plus I sine of n pi by 2, n pi by 2, and also plus here, plus, so the second condition right hand side 2 to the power of n into cos of minus n pi by 2, and here plus I sine of minus n pi by 2. See finally what we get in both the terms, in this term and in this term, we have clearly 2 to the power of n is common. So if you take 2 power n common, so then we get here cos of n pi by 2 plus I sine of n pi by 2, n pi by 2, and here plus, so cos of minus theta, that is only cos theta, this is cos n pi by 2, and here, so sine of minus theta is minus sine theta, so minus I sine of n pi by 2 here. So here minus I sine n pi by 2 plus I sine n pi by 2 gets cancelled. So we have here 2 to the power of n into cos n pi by 2 plus cos n pi by 2. So this is 2 cos n pi by 2. So which is equal to here. So 2 power n into 2, that becomes 2 to the power of n plus 1 into cos of n pi by 2. Finally what we can write, therefore 1 plus I whole to the power of 2n and plus 1 minus I, this is LHS, 1 minus I whole to the power of 2n. So what we get here RHS, so that is 2 to the power of n plus 1. So into cos of n pi by 2, like this we can prove the given problem.